Okay, so when you think of a drought, you probably picture cracked, dry earth under a blazing sun, right? It feels like a very local problem. But what if I told you that's only half the story? What if a drought isn't just stuck in one place? What if it can actually travel? I know, it sounds a little weird, doesn't it? The idea of a drought, packing its bags and moving hundreds, maybe even thousands of miles away. But as strange as it sounds, new science is showing that this isn't some wild idea. It's a hidden but very real part of our climate system. So here's the core idea in a nutshell. When a region is in a drought, the ground is bone dry. And with less water in the soil, way less of it can evaporate up into the air. The wind then comes along, picks up this much drier air, and carries it off somewhere else. The result? The region downwind gets less rain. It's like a chain reaction, all happening invisibly, right over our heads. To really get this, we need to think about how water moves around the planet. You can almost picture the atmosphere as this massive, invisible highway system for moisture. So let's break down how this highway can actually become a delivery route for drought. Now, the official sciencey term for this whole thing is moisture transport, and it's a totally fundamental process for, life on Earth. Water evaporates from oceans and land, it hitches a ride on the wind, and it eventually becomes rain somewhere else. But what this new research is showing is that this system, well, it has a dark side, because if there's no moisture to pick up in the first place, that has some serious consequences way down the line. The whole thing really boils down to 5 simple steps. First, a drought hits an area. That dries out the soil, which basically shuts down the local evaporation engine. So the air right above that spot becomes a lot less humid. Then, and this is the key part, the wind picks up this pocket of drier air and just moves it along that atmospheric highway. And finally, that dry air arrives at its new destination, delivering less moisture and potentially kicking off or making a drought even worse over there. So how do we know this really happens? Is this just a cool theory? Nope, not at all. Scientists have dug through decades of climate data to actually map these connections. And what they found looks a whole lot like a series of dominoes, falling one by one right across North America. Our little journey here starts down in northwest Mexico, in the area they've marked as R4. The research shows that when this region gets hit with a drought, it exports less moisture to the north. And the very first domino to fall, that's the U.S. Southwest, region R8, which feels that effect almost immediately with drier conditions. But the chain reaction doesn't just stop there. That new dryness in the Southwest means there's now less moisture available to be carried even further east. So the next domino in line gets tipped over, the Central Rockies, region R10. A drought has now effectively jumped all the way from Mexico into the heart of the Rockies. And here's the final link in this particular chain. Dry conditions in the Rockies then lead to a moisture deficit for places even further downwind. The final stop on this pathway is the U.S. Midwest, those regions marked R11 and R16. So think about that. A drought that may have started in Mexico has now spread across a massive chunk of the continent. Now, timing is super important here. This domino effect isn't happening all year round. The science shows these connections are strongest and happen most often during the summer, specifically from June to August. And that makes perfect sense, right? That's when the sun is at its strongest, evaporation should be at its highest, and all the plants and crops are desperate for water. All right, let's pull this out of the world of theory and look at a real-world event that a lot of us probably remember. The 2012 drought in the U.S. Midwest was just devastating. It hammered agriculture, had huge economic impacts, and it turns out it's a textbook example of a traveling drought in action. This drought didn't just pop up overnight. The agricultural drought conditions actually started building way back in August of 2011. They hit their absolute worst point a full year later in August 2012, and things didn't really get back to normal until the spring of 2013. It was a long, brutal event. So we usually blame these huge droughts on big weather patterns, like a stubborn high-pressure system that just blocks all the storms. And yeah, that's definitely part of the story. But this new research asked a totally different question. Where did the missing rain actually come from? Or maybe a better way to put it is, where did it not come from?
Well, the answer really comes down to one single powerful number, 62%.
So what does that mean? It means 62% of the rainfall deficit during that historic drought was because less moisture was arriving from other land areas upwind, not from the Pacific,
not from the Gulf of Mexico, but from other parts of the North American continent that were also dry. The drought was literally feeding itself across the land.
Look at it this way. Almost 2/3 of the missing water was a continental problem. I mean, sure, the oceans are the ultimate source of all our water, but this just goes to show how much our rainfall really depends on what's happening on the ground, hundreds of miles upwind from us. And this is where a drought can turn into a really nasty, vicious cycle. It's like a double whammy. First, you're getting less imported moisture because those upwind regions are dry, but then, because you're getting less rain, your own local soil dries out, and that shuts down your local evaporation, which means you get less recycled moisture. So less imported rain leads to less local rain, which just makes the drought deeper and deeper.
Okay, so we've seen the science, we've looked at the case study, but what does this all actually mean for us, for how we live? Well, it really forces us to change how we see our continent. We can't just think of it as a collection of separate states or countries anymore. We have to see it as one single, deeply interconnected water system.
So what are the big takeaways here? Well, for one, the rain in your backyard could literally depend on a forest or a farm 1,000 miles away. And that means land use choices, like deforestation or how we manage agriculture, can have consequences that ripple out far beyond their immediate area. It suggests we need to start thinking about managing precipitation sheds, just like we manage watersheds. And that's going to take a level of regional cooperation we've never really thought about before. This is really the big shift in thinking. And the scientists who did this research put it perfectly. We can't just look at a bunch of different droughts happening across a continent and just write them off as random bad luck from the atmosphere. We now have solid evidence that they can be linked, that one drought can actually cause, or at least worsen, another. And that leaves us with this one final massive question. We have laws and treaties for rivers that cross state lines or international borders. But what do you do when the river is in the sky? If the rain that falls on your farm starts its journey in another country or another state, who's responsible for it? Who governs it? It's a huge, complicated question, and one we now know we absolutely have to start asking.